Hello, I'm Samuel Sennett, Assistant Professor at Portland State University. We're going to be talking about identifying a research problem. In this presentation, we're going to focus on identifying a research problem, go over a few key research terms, and then talk about how to formulate research questions. I think this chapter in the text is fantastic and a real gift to you for where you're at. Identifying a research problem. This is huge. This is very, very important. You want to get into a topic, problem that you really care about. And it's really important to find the right balance of broad to narrow. Oftentimes, where you're at, you're going to struggle with being too broad. Developing a solid research question is the way to start striking that balance. So, jump in with what you're interested in. Personal interest is a great place to start here. And you can also browse educational journals, especially the published online first sections. Look in the news, just be aware of what you care about. So here are some preliminary considerations. Again, you know, go back to your personal interest. This is important. And this week in the class, we're sharing a survey together looking at our interests. Um, so the topic should be important and significant for someone, to make a difference for someone. You also might want to think about doing something unique or new. Uh, you're going to want to pay careful attention to the amount of time needed to study this topic. It might be something too big for your master's project. And again, similar to that, you're going to want to think about how difficult this is going to be. Again, related to the amount of time, difficulty, is how much is this going to cost? You all are graduate students last time I checked, and you don't have a huge budget for your research project, most likely. And then last but not least, you're going to want to really think about ethics of your study and make sure that it's the right fit, especially if you're doing action research in your own classroom. Now, you got to drill down on your topic. You have to limit your topic. Most of the time, topics are too broad or too vague. This is a classic thing. You get interested, you're thinking about a topic, and the table in the text, the table 3.1, is great for showing examples of things that are more narrowed down. And like I said before, if you can state specific research questions or hypotheses, this will also help you with focusing down your topic. And those sample lists in the chapter I found very interesting, very helpful. So here's a couple research terms to help you or help you describe for you. The problem statement. This is huge. One of our writing experts here says that one of the most frequent ways that studies get rejected from journals or have trouble getting through review is that they don't really have a clear problem statement. They don't have a clear point. And this is, describing your research as a complete sentence, or your research problem as a complete sentence. So definitely you want to have this. And you're also going to have a research question. And this term variables, these are characteristics that vary from one person or entity to the next. We talked a little bit about independent and dependent variables last time. You're going to want to think about variables as characteristics, especially when you're looking at correlational research, where you have a lot of different characteristics or variables that you may be looking at or considering inside of a person or population. And the old research question. This is what you're asking in your research. This is the kind of overarching and most likely very specific set of questions that will guide your inquiry. Hypotheses. These are statements serving as predictions as to the outcome of the study. So you can state this as a main hypothesis in these group design studies and some of the correlational and prediction type studies. you're going to state a null hypothesis. And it may take a little while to get used to this idea of a null hypothesis. But basically you say, I predict that nothing will happen, no difference. And then what you really think will happen, this is the research or alternative hypothesis, the HA. And so you have this alternative hypothesis. This is what you, the researcher, actually expect to find. And it seems funny to say, nothing will happen, that's my hypothesis. And then you do the study to see if something did happen. And then you reject the null hypothesis, is what you most likely hope for or think will happen. And inside of that, those alternative or research hypotheses can be directional, where you specify the result. The hypothesis is that the student will make an increase in communication turns, or a student will read faster or read more fluently in words per minute. Or non-directional, specifically that the result and the direction of the result are not specified. Okay. So continuous variables are variables that you can measure along a gradation or have sorry, continuous variables are those that measure characteristics in a gradational differences along continuum. So you can think about certain test scores fitting this profile, temperature, if you're looking at skin conductance and skin temperature. Oral reading fluency would fit this as a continuous variable. So I hope you get the sense of that. We can discuss that more if you're interested. Discrete variables, these are things that have different categories. Things like student, teacher, parent. These are discrete variables. They're dichotomous typically, or they can be dichotomous. So also there's variables that just kind of are in between as well. So we're going to look at scales of measurement. You may have learned about this before. We're going to do a brief review here. So we have nominal, ordinal, interval, and ratio. And the way to think about nominal is the word nominal comes from name, and simple assignment of a name or label to a category. Ordinal, you can think about this as order, right? Ranking. Interval, this is where you're looking at adjacent values representing equal intervals, these equal jumps in between each of the steps. And then ratio, where this is having basically an interval scale plus it has a true 0 point. So let's take a deeper look at these. So let's talk a little bit more about scales of measurement. So here are the scales. You can see that nominal, right? That was the name, like a football jersey. Ordinal, you see a gold medal here. Think about the ranking. You could get gold medal. That's the first place. Silver, second place, third place, bronze. Interval, right? We have a thermometer there looking at the temperature. Right? Those are equal steps. And then ratio, where you have a true 0. Think about your speed. It can go down to 0. So nominal scales. These are descriptors. They're for identification. Adjacent values have no inherent relationship. You can look at those baseball jerseys. The numbers don't really mean anything other than as labels or descriptors. So nominal scales, here's a few other examples. Male and female, yes and no. Used a pencil, typed an answer. So you can think about the uses in assessment. And there's also some limitations to nominal scales, of course. So ordinal scales. You can think about rank ordering. And adjacent numbers do mean something here, but they're just higher or lower. It's a ranking. And the differences don't reflect some order of magnitude. You could certainly use these in different ways than nominal scales in assessment, but they still have limits, okay? Because they're just a ranking. You don't get that difference between 1 and 2, 2 and 3. it doesn't really say anything in ordinal scale about those things. So as we're progressing through these scales, we can look at interval scales. Here in the classic example is a thermometer. 80 degrees is not, although twice as hot as 40. It's looking at without that true zero, you can't kind of base it that way, but you can look at the numerical units are being equidistant. And most tests in education and psychology fit are an interval scale. So there's good things about this, bad things about this. As we go on, you see various examples. You can call those out. So ratio scales, again, this has everything that the says everything that the interval scale has. Excuse me, lost my train of thought for a second. But it has an absolute zero, like number of turns, behaviors. Think about count variables as fitting ratio scales. And again, there's pluses to this, downsides to this. As you go through the course, or as you go through your research, this is something to think about. What scale is your measurement? So when in doubt, try to use a higher scale. Here's an example. So don't start by grading students as below average, average, above average. Give a numerical score, and then you can categorize. So hopefully that gave you a little bit of a clarification about scales. You've probably heard about them in the past. There's a couple of intricacies that I'm trying to kind of get into a little bit, but don't go too wild with this. Just get the sense of what they mean and the basic definition and move on. So here's a few other terminology items. So we talked a little bit about this last week. Independent variables. These are what you're exerting influence on. This is the variable that you're manipulating and that you have control of, and then you're trying to impact that dependent variable. This is the ultimate interest in a study. These are our outcomes we talked about. And then here's another type of variable, confounding. These are traits not considered by a researcher, but may still influence the outcome of the study. And we say there's a confounding variable that we're unsure about, and unsure about its role and its impact on the outcome of the study. So you can think about, say, in the area of literacy instruction, motivation may be a confounding variable. You might not have been able to factor that in to how well your intervention worked or did not work. It may be a confounding variable. Oops. So research questions and hypotheses. Again, go back to the chapter here. That table 3.2 is a fantastic resource, and you can look at the different examples they have about research questions. And a couple quick guidelines. Qualitative questions should be more open-ended, and quantitative questions should be more focused or more specific. And typically, research questions don't have a yes or no answer. So here's a few other guidelines. It's important to think about research questions not begging a question. All right, so they shouldn't be stated in a manner that assumes an answer even before you even begun. So again, back to that balance. You don't want it to be too broad, too specific. You're trying to hit it right at the level of your question and your interest and what's developmentally appropriate in the research line. It's important to base your research question on a body of related literature, especially with quantitative studies. And also, you have to think about the feasibility or the answerability of your research question. That if you are asking a question, you have to match it with the type of data you're going to collect. Here's a couple other guidelines. You're going to delve into the ethics in the next chapter and in the CITI training or the NIH training. If you plan to go on, do more research, do that one. So they have to be ethical and they should be important. So they should really matter. So these questions and these areas that you're thinking about, such as literacy instruction for students with disabilities or communication interventions for children with complex communication needs, these things matter. Getting assistive technologies to people with disabilities, these matter. This is very important for the people of concern. And so hypotheses, here's a note, are typically only used in studies that require the use of inferential statistics. I describe them as group design studies, or it could be correlational or predictive studies. So you can use hypotheses in your proposals. Typically NIH research, you're going to state things as a hypothesis. But that's absolutely correct that in most single case design studies or qualitative studies, you're not going to state it as that hypothesis structure, like the null and the alternative. You may use the word hypothesis, but it's not going to be that formal hypothesis that they're talking about here. So here's my research question for my dissertation, and let's take a look at it to close out this lecture. I'm going to read it out loud. What is the impact of Modeler for Read and Talk on, one, the educational assistant instructional performance, and two, the student communication turns during shared storybook reading? All right, so let's think about those tips, kind of break this down. One, this is a quantitative study, so we want it to be more focused. I'd say check. Yeah, that's fairly focused. I can identify the intervention. That's the Modeler for Read and Talk. And then this classic formula is what is the impact of X on Y for Z? So we can look at that and say, what is the impact of X? That would be the intervention, the Modeler for Read and Talk. On Y, here's what it's impacting. One, it's impacting the educational assistant. And two, it's impacting the student. And what is that? Well, specifically, it's EA's instructional performance, and then the student's communication turns. And then, so on Z, well, it's kind of packed in there, in that same phrase, but we got the who there, both the educational assistant and the student. And we also have a little bit about the context during shared storybook reading. So it got me through my dissertation and, passed with flying colors. So I think this is a pretty good research question. You may see some sort of hole in it, but for a single case design study, this is good as an overarching question. You may have sub-questions, you may drill down even further, but here's an example for you, and I'd love to talk with you about this specific study. So thanks for listening to this presentation.